school new math set theory. Well, we're going to introduce the set theory. In high school, the somewhat covers mostly the practices to get used to the concept. And one important thing you have to learn is the necessary condition and the sufficient condition. And sufficient, necessary condition, and the inverse conditions, and opposite condition, so and so. Okay, so first of all, notation we use a group of element. Group is written like that, A and B. So this group has A and B. The food, all the foods are in a group, living things. Okay, apple, orange, turtle, etc. Now, apple is an element of food. Is one of food is apple, so this means element of the group. Okay, and the fruits group can be element of food. It's a subset. It can be subset, right? And apple, again, it's a fruit. Axiom in the set theory is if subset 1 belongs to subset 2 and subset 2 belongs to set 3, then subset 1 is part of set 3. So what it's saying is subset 1 and 2 and 3. So if 1 belongs to 2, 2 belongs to 3, then 1 should belong to 3. So this is obvious correctness, okay? And subset 1 belongs to subset 3, and subset 2 does not belong to subset 3. Then subset 2 doesn't belong to subset 1. It's not the element of. This is not element of. So you have a subset 1 is inside subset 3, and subset 2 doesn't belong. It's not even overlapping. Okay, then subset 2 is not the part of subset 1. It's isolated. Okay, so these two are axioms in set theory. Now terminology, we said it right. This means this is A, group A and B. This means intersection and represent this area. That's subset. And in the logic, when you go to computers or electrical engineering, you learn the logical theory. The logic, we call this AND. Okay, and this one is we call union. Union means A and B together. So it's going to be this area. Okay, and then in the logic theory we call OR. In the logic theory we will use a multiplication dot. This one we use plus dot. So in the computer, A plus B means A or B. A dot B means A and B. And this is an intersection. This is a union. Okay. Find the subset defined by the following notation. A is even integer, B is integer less than 10. So even integer and less than 10. So if it's union, 1, 3, 6, 7, 9 has to be added, right? We have to put the positive, and it's an intersection. Then even integer 2, 4, 6, 8 and integer less than 10. So only 2, 4, 6, 8. 10, 12 doesn't belong here. Okay? Okay, so state if the following statements are true or not. Goldfish are fish, and fish live in the water. Then goldfish live in the water. So this one is goldfish is element of fish, and fish element of a subgroup, subset of anything living in the water. So goldfish living in the water. So this is the axiom, the first axiom. So this is obviously correct. In the statement above is a condition goldfish is a subset of fish. The sufficient condition of goldfish is anything living in the water. Yes, this is a sufficient condition. When subset is completely inside, it's a sufficient condition. Okay? But this outside is necessary condition for this. So B is necessary condition for A, and A is sufficient condition for B. Because if A, for sure it belongs to B, right? But in order to be A, at least you had to be within B. Otherwise, second axiom said if you don't belong to A outside, it's isolated, it cannot be A. Okay, so what is the necessary sufficient condition? When A and B are completely in agreement, right? Okay. Find a subset defined by the following notation. This is a little bit practice. It said add integer and this. So union is add integer. Add integer cover this A. And the intersection is this A. Right? Positive integer and A and B, the union is you all collect every element here, and intersect is find the number which exists on both sides. For question 2 and 3 above, state if the following condition. Okay, here the necessary condition, sufficient condition, and necessary and sufficient condition. Okay. State if the following statements are true or not. If vegetable is a plant and B is not a plant, then the B cannot be a vegetable. Yep. So this is a axiom, second axiom, right? Vegetable is a plant, and the B is not the plant, it's outside. So B cannot be vegetable, it's isolated. Okay. If the statement above, what is the necessary condition for B to be vegetable? Well, the B has to be the part of plants, but B is an insect, so it's not. Now Venn diagram. This is the Venn diagram, and if element E above belongs to A, then E belongs to B. Is that true? If element E belongs to A, then E belongs to B. This is incorrect, right? Incorrect. The subgroup is the element of B. A is the subgroup of B. Oh, if element E belongs to A, E belongs to B, E could be this one. E completely belongs to A. So this is incorrect. If A belongs to B, A belongs to B, then A not belongs to B incorrect. This is not. Okay, the bar, the group set A, if you put the bar, that means everything else other than this group. Okay, so this is incorrect. Check the following equations are correct. Okay, here's a practice. Go ahead and stop the video and verify, see if its answer is correct. Sometimes answer is incorrect, so you have to pay attention. Class of 36 students has 21 boys, 12 children scored over 90 points. There are two conditions. So scored 90 points and the boy is 21. So how many girls scores? If twice as many as number of boys. Okay, so this is set O, this is everybody, right? And the girl who got over 90 points is twice as large as the boy who got 90 points. How many girls scores more? Scored more than 90 points. Okay, so number of girls who scored more than 90 points is X. So 36 minus 21, okay, is minus X is 2 times 12 minus X, right? So it's 9 girls. Okay, so it's quite a complicated case. If you use Venn diagram, you can do it. This is also quite complicated. I think you have to stop the video and stare at this and try to figure out. The answer is here. Okay, try this out to get used to the Venn diagram. The Venn diagram is a key for set theory. Venn diagram. Okay, thank you for listening, and I'll see you next time.